Okay, Assalamu alaikum. Welcome back, guys. We are on to the third video now about this connected particles. Okay, this is basically we are moving towards the climax of this chapter. Okay, this is becoming more and more interesting and maybe complicated for some of us. Okay, so now we have these connected particles now, and now the string, you can see that is passing over the pulleys. Okay, and in some cases we have the horizontal surfaces, there are some like inclined surfaces. Okay, so I'm just going to read out the first question of this exercise 5. It says in each of the following diagrams the blocks are at rest. Okay, so that is a very important information. All these blocks are at rest and they are connected by light strings passing over smooth pulleys. Any hanging portion of a string is vertical and any other portion is parallel to the surface unless marked otherwise. The surfaces are rough and horizontal. Okay, in each case the magnitude of the tension in the string and magnitude of any, like we have to find the magnitude of the tension in each string and the magnitude of any frictional force. Okay, now I'm just going to focus on this first part. Okay, the part A. Look at this. Now this guy has a mass of 3 kg, so I should be showing its weight as 30 newtons. Okay, so there is a tension in the string which is going to hold this. Okay, and here is the tension. Now there is a people have made a simple formula that whenever you have connected particles and the string is passing over a full pulley, so just show the tensions directed towards the pulley. So that is just a basic formula. If you want to ratify this, you show the tensions directed towards the pulley. Otherwise, if you want to know the concept behind it, the thing is that this block of mass 3 kg is stuck. It is pull upwards because of this block over here. It is connected with this block. Okay, so that is why we have the tension upwards over here. Similarly, we are showing this tension towards the pulley because there is a thrust on this block because of this guy of mass 3 kg. Okay, so now the thing is that since these are at rest, so this is basically a state of equilibrium over here. Okay, so we can say that the tension in the string right now, that is 30 newtons. Okay, and obviously there has to be a frictional force. Let me call this x newtons, only because of that frictional force this is at rest. Okay, if this was a smooth surface, then this system should be moving. Okay, so this tension is same as, the frictional force is going to be same as this tension. There is no need to show this r over here. Okay, if we were asked to find maybe the coefficient of friction, then we could have used this, if this weight is going to be 40 newtons here, so this r would be 40 newtons, and then obviously you can determine the coefficient of friction over here. Okay, now moving towards the B part. Now this B part, okay, I'll come back to this B part at the very end. Okay, now let's move towards the C part. So here is this guy of the mass 4 kg, so shall be showing its weight downwards. That is going to be 40 newtons. Okay, now you must be very good player of resolving this weight. Okay, parallel and perpendicular to this surface. Okay, so we don't need this r right now. Okay, so we just need this part over here. This is going to be 40 sine 30. Okay, and this guy's weight is going to be 30 newtons. So here is the tension which is stopping this 3 kg block to go down to the ground. Okay, and here is this T over here. Okay, so now both of these two particles, they are at rest. Okay, they are not moving. So first of all, I should be allowed to say that this T is equal to 30. Guys, there is a state of equilibrium, so upward force equal to downward force. So in this case we have T equal to 30 newtons. Now this T is same as this T over here, so you have this 30 newtons over here. Now you can find this 40 sine 30 mentally because sine 30 is half, so the component of the weight down this inclined plane parallel to it is going to be 20. So obviously there is a frictional force helping this weight to balance this tension over here. Okay, so we can say that this T is going to be, for this block, this T is going to be x plus 40 sine 30. So you will get that x from here. Okay, now moving to the D part, we're given that this this is a smooth surface over here. Okay, so I'm just going to use this. Okay, first of all, you have, this is going to be 30 newtons, and here is the R. Let me call this R1. Okay, this guy's weight is going to be 40 newtons. Okay, guys, this diagram is coming again and again in your lives. Okay, so you will be resolving it like this. Okay, let me call this R2 for this block. Okay, and this is going to be this component is going to be 40 sine 30, and this is going to be, like, we don't need this 40 cos 30 because this is already smooth, so there is no need of this R over here. Okay, so here is the tension trying to pull this, and this is the tension over here. Okay, so now this surface is smooth over here, and this is obviously rough. That is why this is not moving. Okay, so let me show that frictional force towards this direction. Okay, so now in this case, for this 4 kg block, this tension is simply equal to 40 sine 30 because this is at rest. This is the only force upward and this is the only force downward. Okay, this T is equal to 40 sine 30. So let me call this T is equal to 40 sine 30, and that is going to be 20 newtons. Okay, so coming towards this block, so this X has to be 20 Newton, only then this block can remain at rest. Okay, so this was the D part. Now moving towards this part B. Now what is special in this? What is different if you look at this, you compare this with the other 3 parts? The thing is that this, in this situation, we have a block connected with 2 other blocks over here. Okay, so now these 3 examples, these 3 examples had just 1 string in them. Okay, now here are 2 strings. So please remember, 1 string, 1 string, 1 string, the same tension. But when you have 2 different strings, then there will be 2 different tensions in them. Okay, so if I, like, I'm showing this weight downwards, which is 50 newtons over here, this is going to be 30 newtons over here. So if I write this tension as T1, so I should be giving another name like T2. Okay, so here is this T1, here is this T2. Okay, now this T1 is clearly 50 newtons because upward force equal to the downward force. Okay, so this is established that this is 50 newtons. So this is going to be, like, this is this T1. I'm just going to show it over here, 50 newtons. Okay, and this T2 is again the state of equilibrium, so that T2 is going to be 30 newtons. So I'm just going to show this over here. This is 30 newtons. So guys, in which direction do you think the friction is acting? Towards the 5 kg block or towards the 3 kg block? Yeah, towards the 3 kg block, because this block, again, it is at rest. This is not moving. So this 50 can only balance this 30 if there is that plus X over here. Okay, so this X is definitely going to be 20 newtons. Okay, so this was the 3rd video on this. I'll be moving towards some harder questions in the next video. So stay tuned, guys. Do subscribe, do share, do like it. Okay, thank you very much.